Hello friends, welcome to Unacademy Studios Bridge. As you know, we are currently solving gate questions that they have asked in axial loading chapter. For axial loading, I've already discussed about 1 mark problems. And just in case if you have not watched that 1 mark problem session, then first of all you complete that one and then you come back to this one. And by the end of the session, you will be able to solve problems based on axial loading, because there are certain concepts that you must keep in mind. There are 4 or 5 concepts I told you, and if you keep all those 4 or 5 concepts in mind, then you can easily and you can quickly solve all the problems that they have asked in axial loading chapter. Just in case if you are new to me, if you are attending me for the first time, I'm Marut Tiwari, and let me briefly introduce myself to you. I've done my masters from IIT Kharagpur and I've been a recipient of multiple awards there. I've cracked GATE multiple times, and I'm also an author of the book. GATE in 75 Days, and I'm proud to tell you that it is one of the best sellers in GATE segment. Follow me on Unacademy to subscribe and to watch to my live sessions. Follow me on Unacademy at this particular link. Currently, I'm associated with Unacademy, and Unacademy is having an outstanding pool of educators, like a very good pool of number of educators are there who can help you in your entire, mechanical engineering learning. Guys, Unacademy provides you number of attractive features, number of advantages are there. And I can tell you number of reasons, I can tell you so many reasons, but I'll tell you three main things. And these 3 main things are, why Unacademy? Why you should choose Unacademy for your GATE learning scenario, for your GATE preparation, why you should go for Unacademy? Because my dear friends, I'll tell you 3 reasons, and these 3 reasons are unmatchable. These 3 reasons are something that nobody else is providing right now. Feature number 1, that you have the choice. Like in conventional classroom coaching programs, you don't have a choice to select the teacher. You don't have a choice to, select the educator. But here you have got the choice. Here you have got the freedom to select your educator. A lot of options are there. If you install an Unacademy learning app, you will see that the same subject is being taught by Mr. A also, and the same subject is being taught by Mr. B also, the same subject is being taught by Mr. C also. So it is up to you that your frequency is being set with which educator. Alright, so number 1, that you have the option, you have the freedom to select the educator, and to select one educator for one course and maybe another educator for another course. Sometimes what happens in classroom coaching programs, that you like one teacher so much that you want to learn more courses from that educator only. But there is compulsion that you can't learn, number of courses from the same educator. Why? Because they have number of educators, and one educator will be allotted one course only. But that is something beautiful regarding Unacademy. Why? Because if you are liking one educator, and if your frequency is set with one educator, then you can follow more courses from that educator alone. So number 1, that you have got complete freedom to select your educator and which course is to be learned from which educator. Number 2, that you have got complete freedom of selecting the time. That day long there are multiple sessions getting live, multiple sessions streaming out there, and you want to select, you can select your own sessions, that whether you are comfortable with morning sessions or evening sessions or afternoon sessions or weekend sessions or whatever. So guys, you have a lot of freedom regarding time also, regarding the sequence, whether you want to learn this course first and then you want to learn mechanics of solids and then fluid mechanics and then thermodynamics, or you want to learn heat transfer first and then thermodynamics. Like you can figure out the best possible sequence suitable for your learning, because every student is different and every student has a different set of convincing factors. So it is up to you. As I said, a lot of features are there. Flexible schedule is there, and you can learn in the language of your choice. You can watch the sessions as many times as you want, and this is how the Unacademy Plus learning screen is going to look like. There you're going to have 70% of the screen occupied with the content, and in the side window the educator will be streaming, the educator will be available live, and you can ask anything in the real time whenever you are on Unacademy app. If you are subscribing for the Plus packages, then you can watch and you can ask, just like a real class, you can ask any query, any doubt to the educator. You can get the response in real time. And then, my dear friends, there are interactive polls floated by the educators. You can participate in them, and you can learn anytime and anywhere. Even in terms of payment, there is a lot of flexibility. You can go for monthly subscription, you can go for 3 months, 6 months, 12 months and 24 months subscription. Alright, so you can go for all these subscription packages out there. I'll recommend you to go for 24 months subscription, because 24 months subscription is available at a very cost effective offers. As a one time payment you pay 40,000 rupees, but if you divide it by 24, roughly it comes down to just 1667 rupees per month. Alright, so you pay just 1667 rupees per month. In fact, if you use my code MTLive, then my dear friends, this can be brought down even further. If you use the code MTLive, then this cost can be brought down even further. Instead of paying 40,000 rupees, you get 10% additional discount and you pay just 36,000 rupees. And after paying 36,000 rupees, it comes down to 1500 rupees per month. Similarly, you can go for 12 months package. 12 months package is available at just 25,000 rupees. Alright, this is unmatchable. Why? Because there is no travel expense, there is no study material expense, there is no classroom AC, and all those expenses are not there. You just have to pay for the educators, and that too, you have the option to select from so many educators. It's not like one-way traffic being imposed on you. It's not like one-way decision being imposed on you. You have got the choice, and that is the biggest beauty of learning from Unacademy. So guys, it's very easy. All you need to do is you need to install Unacademy Learning app. After installing that Unacademy Learning app, you need to select GATE as your goal. After selecting GATE as your goal, you can go for all these packages out there. So go ahead. I wish you very happy learning with Unacademy, and I wish you the best possible All India rank in GATE. Let's go ahead and start this discussion. If you have already watched my previous video, I've discussed the 1 mark problems and their solutions that have been asked in Axial Loading chapter. In Axial Loading chapter, whatever questions they have asked in GATE papers, right from 2001 up to 2019, I have discussed 1 mark problems in the previous session. I'll give you a very quick recapitulation just to tell you that what concepts are needed in Axial Loading chapter to solve 99% of the GATE problems. Number 1, load. Number 2, stress. Number 3, elongation. And number 4, thermal stress. Load will be calculated from either side, and either side. Either you calculate from the left side or you calculate from the right side. It is up to you. You can calculate from any one given side. Wherever you are calculating the load, just cover everything on one side of that section. Just cover everything on the either side of that section. Stress, there are 2 ways to calculate the stress due to axial loading. Stress you can calculate either as P by A, or you can use Hooke's law, which is E delta L by L. Delta L by L is representing the strain value. This delta L by L is representing the strain value. Okay, this is representing the strain value. Now, main thing is delta L. This is very important. Do remember this, PL by EA, and also remember sigma L by E. Just in case if load or elasticity or area is varying, then You use the same formula, but you use it for chotu length, you use it for differential length, you use it for very small length, and then you integrate to get the total change in length. The fourth and final thing, thermal stress. Regarding thermal stress, please do remember that as long as there is no restriction, there will be no thermal stress present. Thermal stress will be present only when there is some restriction. Maybe a complete restriction, maybe a partial restriction, but restriction has to be there. If our body wants to expand and you are allowing it to expand, it is not going to develop any stress. If a body is upon heating, if a body is expanding and you allow it to expand, then it is not going to develop any stress. It is going to develop any stress only when you restrict it. Just like I told you that you are going to resist. Just like I told you in previous video, that if you are in a room and you are locked from all the sides, then you are going to resist. Even if one door is open, then you can, expand from that one door and you are not going to resist. So we have already solved 1 mark problems. All these 1 mark problems we have already solved. We have discussed about them. Let us now go ahead and start solving 2 marks problems. Let us start as a 7th problem. Let us start with this 2 marks problem that they asked in 2004. In 2004, they asked this particular problem where cross-sectional area is 25 mm square and elasticity is given to as 200. Elasticity is given to you as 200 gigapascal, and they are asking you to calculate the delta L value. Length values are also given to you. This much is 500 and this much is 400. So because total is 1700, this middle one will be 1700 minus 900 and this becomes 800 millimeter, isn't it? Now the main thing is load here. Why the main thing is load here? Because you think about it. They are asking to calculate change in length, and change in length formula is what? Change in length formula is P into L divided by E into A. Change in length formula is P into L divided by E into A. Alright, so length is known to you, elasticity is known to you, and area is known to you. The main thing is the load here. Now, how do you calculate the load? Load is, as I already explained, load is calculated from either side. Load is calculated by summing up everything from either side. You can sum up everything from either side. Alright, so you get the load for first segment. You get the load for first segment as nothing but 100 Newton. I'm calculating from the left side. Similarly for the second segment, if I sum up everything from either side, then I have two loads. 100 Newton tensile is there and 250 Newton compressive is there. 100 Newton is tensile for this and 250 Newton is compressive for this. So P2 I get 100 Newton tensile and 250 Newton compressive. P2 value I get minus 150 Newton. Now what about P3? For the third segment, I must calculate from the right side. Why right side? Because right side is easier for third segment. So for third segment I get plus 50 Newton. So now you know the load, plus 100 minus 150 and plus 50. You know the load value. For the first segment you have plus 100 Newton. For the second segment you have minus 150 Newton, and for the third segment you have plus 50 Newton. Now let us go ahead and use the method of superposition to calculate total change in length. The total change in length can be written as change in length for the first segment, change in length for the second segment, change in length for the third segment. Now I can replace them as PL by EA, PL by EA and PL by EA. I can replace them as PL by EA, but because E and A, they are common factors, so I put them as a whole, one common denominator. Now you know all these values. Load values we have already calculated. Load values we have already calculated. For the first segment, load value is plus 100. For the second segment, load value is minus 150. For the third segment, load value is plus 50. Now L1 is what? L1 is what? Let's go back and check. The length for the first segment is 500 mm. The length for the second segment is how much? The length for the second segment is 800 mm. 800 mm. And the length for the third segment is how much? The length for the third segment is 400 mm. Elasticity value is given to you and area value is given to you. Elasticity value and area value, they are again provided to you. Elasticity value is given to you as 200 gigapascal. So 200 into 10 raised to 3 megapascal. Megapascal is also equivalent to Newton per millimeter square. And area is given to you as 25 mm square. So now you can, you know all the values, you can solve for this. And after solving this, you get the final answer. I'm not solving it. I have full faith on you. I know you can do this within a matter of seconds. You can pick the calculator and you can solve for the final change in length because all the values are known to you. My emphasis is on the concepts, that you must know the concept. So which concept we have used? Out of the 4 things that I told you in the very beginning, which concepts we have used here? We have used 2 important concepts here. Number 1, the concept of either side to calculate the load. Number 1, we have used the concept of either side to calculate the load. Number 2, we have used this P into L divided by E into A formula. Now, sometimes let me tell you about the variations. Sometimes they can change the area. Like for first segment, there will be a different area. For the second segment, there will be a different area. For third segment, there will be a different area. Then EA, you'll have to use different. Similarly, sometimes they can use different material and different material for all 3 segments. So you'll have to use P1L1 by E1A1, P2L2 by E2A2, P3L3 by E3A3, like that. Similarly, guys, sometimes they will give you a problem where one side they will provide some support. Then we are going to prefer calculating the load from right side only. Whenever there is a support, then you calculate the load from other side. Why? Can't we calculate the load from the support side here? You can. But to calculate the load from the support side, you'll have to first calculate the support reaction. So these are some, little things that can make your problem solving very quick and very commanding. Alright, so just keep remembering and keep noticing all these things, and after you complete the video, I would recommend you, my dear friends, to solve all these problems by yourself. I'd recommend you to solve all these problems by yourself once again. So let's go ahead, and as an 8th problem, try solving this particular problem that they asked in 2006. This as an 8th problem, this 2006 problem. Here you have a steel bar of square cross section 40 mm by 40 mm, and it is subjected to an axial compressive load of 200 kilonewton. The length of the bar is given as 2 meter and the elasticity is given as 200 gigapascal. We have to calculate the elongation of the bar. So let's go ahead and try calculating this. This is a very easy, very simple thing. Why? Because we have to calculate the change in length. Load is given as 200 kilonewton. So if I change it to Newton, it will become 200 into 10 power 3 Newton. And then length is given to you as 2 meter. So if I convert it to mm, it's gonna be 2000 mm. And then, my dear friends, elasticity value is given to you as 200 gigapascal. If I change it to megapascal, megapascal is also equivalent to Newton per millimeter square. and area value is given to you as 40 multiplied by 40 multiplied by 40 millimeter square. So this is how you solve it in a matter of seconds. And this is a 2 marks problem, mind it. This is a 2 marks problem that they asked in GATE 2006. This Newton and Newton and this mm square and mm square, they are going to kill each other and you'll have only mm left end of the day. So this 200 and 200 and 10 power 3 is also going to get cancelled, and here 0 0 is going to get cancelled. You'll get 20 divided by 16 mm, and 20 divided by 16 mm is nothing but 1.25 mm. So as far as the magnitude is concerned, the magnitude of the elongation is 1.25 mm. This was obviously a very simple problem, a very easy formula based problem. As a 9th problem, let us try solving. As a 9th problem, let us try solving problem that they asked in 2006 once again. A bar is having a cross-sectional area of 700 millimeter square. A bar is having cross-sectional area of 700 millimeter square, and it is subjected to axial loads at the positions indicated. The value of stress you have to calculate in BC segment. Now you must be wondering, where is the indicated figure? Don't worry, I'm going to show you the figure first of all, because somehow the figure is missing here. No problem. I remember this particular problem that they asked in 2006. My dear friends, in this particular problem they divided entire bar into 4 segments, and then they introduced a 63 kilonewton load at A. Then they introduced a 21 kilonewton load at D, and then they introduced a 35 kilonewton load at junction B, and finally 49 kilonewton load here at junction C. And they asked that what is going to be the stress, value in BC segment. So to calculate the stress value due to axial loading, you know, simple formula, P by A. Of course, if you are calculating the stress in BC segment, then load must also be for BC segment and area must also be for BC segment. So what is the load for BC segment? Suppose if I calculate from the right side. In fact, you can calculate from the left side also and you will get the same value. As I have repeatedly told to you that if you calculate in the BC segment, okay, let me verify this. Let me just in front of you verify this to satisfy you, to convince you that in BC segment, if I calculate the load from left side, then I have 63 kilonewton tensile and 35 kilonewton compressive. The 63 minus 35 is going to be what? 63 minus 35 is going to be how much? This is going to be 28 kilonewton, and this I have calculated from the left side. Now let us calculate from the right side. If I calculate on BC segment, if I calculate the load from the right side, on the right side you have two loads. You have 49 kilonewton and you have 21 kilonewton, isn't it? 49 kilonewton is tensile, and 21 kilonewton is compressive. So once again, you get 49 minus 21 as what? 49 minus 21, once again you get 28 kilonewton. And this is not like, you know, one problem where it is working. This is going to work in any given problem of mechanics of solids. Why? Because in mechanics of solids, virtually and inherently you will have equilibrium in 99% of the structures. So therefore you will get the same value, not only the same value, but also the same sign, whether you calculate from the left side or you calculate from the right side. So what is the load here? The load is 28,000 Newton. And what about the area? The area is 700 millimeter square. Now this 0 and 0 is going to get cancelled and you will get 40 Newton per millimeter square. As I already told Newton per millimeter square is also known as megapascal. So you get the answer, 40 megapascal. Congratulations, you get 2 marks. Let us now try solving as a 10th problem. Let us try solving this 2 marks problem they asked in 2012. This is a problem based on thermal stress, and the main thing is here this line, that a bar 200 mm long and elasticity is 200 gigapascal, alpha value is 1 into 10 raised to minus 5, and the temperature is being increased by 250 degrees Celsius. It has been fixed into immovable rigid walls. This is the main thing, that this particular bar has been kept between 2 immovable rigid walls. That is the main thing, that we are keeping that rod, we are keeping that bar in between 2 immovable rigid walls. The length for this is given as 200 millimeter, and elasticity is given as 200 gigapascal. Alpha value is given as 1 into 10 raised to minus 5 per degree Celsius, and the temperature is being raised. The temperature is being raised by 250 degrees Celsius. If you have completed watching the previous video that I made for axial loading gate problems, then you already know, you have a little bit of idea that how to approach to thermal stress problems. But just in case if you haven't watched, no problem, you're still going to understand this. You see, I told you that if restriction is there, then thermal stress will be present. If restriction is not there, then thermal stress will not be present. Now you think about it. Do we have a restriction here or not? Sir, obviously we have a restriction. Why? Because this door is locked and this door is locked. You are not allowing the rod to expand anywhere. You are not allowing the rod to expand to increase its length either in the left side or in the right side. So it's completely restricted. This is what we call complete restriction. This is what we call complete restriction. Don't worry, today itself I'm also going to solve partial restriction case. Alright, in a matter of maximum 5 to 10 minutes, I'm going to solve another problem that will be based on partial restriction. So this is complete restriction, guys. Stress will be present. How do you calculate a stress? Thermal stress. I told you thermal stress you calculate on the basis of restricted strain. On the basis of restricted strain, and this restricted strain can be written as the expansion that has been restricted divided by original length. Now, how much is the restricted expansion? Sir, total expansion is restricted. You are not permitting the rod to expand by even 0.00001 mm. So you're completely killing the expansion. And if you're completely killing the expansion, then my dear friends, total expansion you are killing only. So L is going to get cancelled. And if L is going to get cancelled, we get E alpha delta T. This is what we get. Now you can put the values. E value is given, alpha value is given, and delta T value is given. So let us put the values. We get the thermal stress here as E alpha delta T. E value is given to us as 200 gigapascal. Alpha value is given to us as 1 into 10 raised to minus 5. And delta T, E value is given as 200 gigapascal, alpha is given as 1 into 10 raised to minus 5, and delta T is given as 250 degrees Celsius. So you get the final answer as what? This 10 power 3 and 10 power 2 is going to nullify this 10 power minus 5, this 10 power minus 5, and we are left with 2, and we are left with 250. So we get final answer as 500 megapascal as the final answer. Congratulations, sir. You get 2 marks once again. Now let me solve this 2015 problem. Let me solve this 2015 problem as an 11th problem. Let me solve this 2015 problem that they asked for 2 marks. Once again, we have a metallic bar of uniform cross section. Specific weight is given for that bar, 100 kilonewton per meter cube. And it is suspended vertically. Vertically it is hanging down, just like this. Vertically it is hanging down. So there is this bar of uniform cross section. There is this bar of uniform cross section, and this bar of uniform cross section, my dear friends, is suspended vertically like this. Obviously it must have been fixed. It must have been fixed at one extreme, and then they are asking, due to its own weight, what is going to be, due to its own weight, if the length is 100 mm, this is a misprint here, it is not 100 meter, it is 100 mm only, and elasticity value is 200 gigapascal. Then they are asking what will be the elongation of the bar due to its own weight. So let us go ahead and calculate this. First of all, we'll try calculating the load. Why the load? First of all, we'll try calculating the load at any given, what the hell? First of all, we'll try calculating the load at any given position x. Let's say we select a section at x position from one extreme, and we follow the concept of either side. We follow the concept of either side to calculate the load. So what is the load here? The load is nothing but the weight itself. And in this much length, we have the weight of, number of particles out there. So this much weight we'll have to consider. This much weight we'll have to consider. We'll have to take this much weight. Now how much is this much weight? This much weight is specific weight multiplied by volume. Specific weight multiplied by volume of this x length. So volume of this x length is going to be simply area multiplied by this x length. So you get the load at x position as what? You get the load at x position as gamma AX. Now just in case if you don't understand this, first of all, let me clarify that I'm not using any new concept. I'm just using either side, either side, either side, and either side. That's it. First of all, please be assured and make sure that you understand this, that I'm selecting a section somewhere and then I'm calculating the load from either side of that particular section. Number two, that what is this specific weight? Specific weight is nothing but weight per unit volume. That's why I've taken specific weight multiplied by volume, that becomes weight. Now let us go ahead and calculate the elongation, calculate the change in length. The change in length formula is what? The change in length formula is PL by EA, but you are not allowed to use it. But don't dare use this formula. Why? Because the load is changing with x, and if the load is changing with x, load is, my dear friends, load is changing with x. And if the load is changing with x, then you can't use this formula. If you remember, I told you already the concept for this, that for this scenario, my dear friends, just in case if something is changing, then you should use PL by EA for a differential length, and then you should integrate it. So P is what? P is gamma AX, and then you have dx divided by E into A is a common factor here. So if it is a common factor, it's going to get cancelled. And then you are left with what? Then you are left with gamma, which is a fixed value, E, which is a fixed value, and integration of x is gonna be x square by 2. From 0 to L, you can integrate this. So you'll get delta L value simply as gamma L square divided by 2E. If you want, you can remember this for a prismatic member subjected to self-weight. This is the elongation formula for a prismatic member subjected to self-weight. Now gamma value is given to you and L value is given to you. Gamma value is provided here and L value is provided as 100 mm. This is 100 mm, not meter. And then you have 200 gigapascal as E value. So everything is given. I hope you can solve this. And after solving this, in a matter of seconds, you'll get the final numerical answer. So this was, once again, what we are using here. We are using PL by EA, but through a differential approach. Why? Because something is changing. Though I will recommend you to directly remember this self-weight elongation formula, this gamma L square by 2E. Okay, so directly remember this so that in future if you get one such problem in front of you, then you can directly use this. But my dear friends, for any problem where load or elasticity or area is changing with x, there you have to use this funda only, P dx by EA, and then integration. I'll solve one more problem like this. Wait, I'll solve one more problem like this. Okay, let me first solve this type of problem only. This type of problem they asked in 2017. Let me solve this and then I'll get back to other problems. So this particular problem they asked in GATE 2017, where we are once again going to use that, chotu length concept. Why? You will know. As a problem number 15, I'm going to use this. I'm going to solve this 2017 problem. They asked for 2 marks. A horizontal bar fixed at one end. Now wherever it is fixed, that is x is equal to 0. That is origin. Has a length of 1 meter in cross-sectional area of 100 millimeter square. Its elastic modulus is varying as 100 e power minus x gigapascal, where x is the length. X is the length in meter. X is the length in meter along the axis of the bar. Now this bar is subjected to 10 kilonewton load at the free end. At the free end where x is equal to 1. Then you have to calculate the axial displacement at the free end. You have to calculate axial displacement at the free end. So we have got a bar, and that bar is having x is equal to 0 here and x is equal to 1 here. So total length is 1 meter and it is subjected to 10 kilonewton load. Elasticity of the bar is varying with x as 100 into e power minus x gigapascal, where x must be in meter. X must be in meter to use this relation, and area is given to you. Area of cross section is given to you as 100 millimeter square. So are we going to use, to calculate the change in length, to calculate the displacement, are we going to use PL by EA? No. Why no? Because something is varying here. So this PL by EA thing we can't use. We can't use this PL by EA thing. We will have to use same formula but for chotu length, but for differential length, and then we will have to integrate it for total length. Now load value is what? Load value is given to you 10 kilonewton. It's a constant thing. Load value is given to you 10 kilonewton. I'm changing it to Newton. And area also is a constant thing here. Area is 100 mm square. So load is in Newton and area is in millimeter square. And then my dear friends, we are left with dx and we are left with E. Now E value is given to you as 100 e power minus x gigapascal. Let me change it to megapascal. Let me change it to megapascal. If I change it to megapascal, then megapascal means what? Megapascal means Newton per mm square. So you have Newton per mm square here and you have Newton per mm square here. It's going to get dismissed. Alright. Now, one thing that you'll have to be mindful about is that x must be kept in meter. Why? Because it's very clearly written that if you want to use this relation of E, then x must be kept in meter. So now you get, everything is getting cancelled here. This 110 power 3 and 100 will get cancelled with this 10,000. I'm sorry, this 10 power 3 will still be there. This 10 power 3 will still be there. So we get delta L value as what? We get delta L value as 10 power minus 3 and e power x integration from 0 to 1. It is a one line thing you can solve, and once again you get 2 marks. That's how you do it. Like, it's a very simple thing. You see, it's a very simple thing. Now let me solve these remaining problems that we left in between. So let's get back to this problem number 12. As a problem number 12, let's try solving this particular problem they asked in 2016 for 2 marks. In this particular problem, we have a bar ABC, and that bar ABC is having 2 loads here. They are saying that if the displacement at C here, if the displacement at this final point has to be 0. Now if the displacement or deflection at this final point has to be 0, that means overall elongation is not allowed. Because if overall the bar is going to elongate, then naturally here you're going to have some displacement, here you're going to have some deflection. Alright, so what you have to do here is that if displacement or deflection at C is 0, then my dear friends, total change in length is not allowed. So overall, you will have to set overall displacement to be 0. Now overall displacement I can break into 2 displacements. The displacement or the elongation for AB segment and the displacement or the elongation for BC segment. Now AB segment and BC segment, for both of them I can write PL by EA. L is common for both of them. E is different, but A is again common. So if I write PL by EA for both of them, then L by A can be taken as common, and I can write for AB segment, I can write P divided by E, and also for BC segment I can write P divided by E. So basically guys, I'm writing PL by EA for each segment, but then L is a common thing for both the segments and also A is a common thing for both the segments. Alright, so L and A, they are the common things for both the segments. Now what is the load in AB segment? Once again I'm going to use the either side concept. So if I'm going to use the either side concept, and if I calculate from the right side, you can very clearly see that for AB segment the load is minus P plus F for AB segment. And by the way, this L and A, this is going to get killed with a 0 value. For AB segment we have the load minus P plus F, and for AB segment the elasticity value is 3E. For BC segment, what is the load? For BC segment the load value is plus F. For BC segment, once again I am following the concept of either side. I told you that no matter what, load will be calculated by using only one and very powerful concept, and that powerful concept is either side. So for BC segment, what is the load value? For BC segment the load value is F tensile, and once again elasticity value is given to you even for BC segment. Now E is a common factor, and because the other side is 0, so E is also going to get cancelled. So from here if I multiply by 3, I get minus P plus F plus 3F is equal to 0, isn't it? And then my dear friends, we have minus P and 3F and F, this will become 4F is equal to 0. So this finally becomes P is equal to 4F, and this is how you get the required ratio. P divided by F is equal to 4. Congratulations, you get 2 marks. Alright, so you get 2 marks here. Once again, this was 2016 problem and we solved it within a matter of a minute. Within a matter of a minute, we completed it just by using delta L formula, PL by EA, and by using the concept either side. Now let us go ahead and as 13th problem, let us try solving this as 13th problem. Let us try solving this particular problem that they asked in 2016 for 2 marks. Now this is a little confusing problem. This is a problem that confused so many students out there. Here, my dear friends, they are giving you the load value and they are giving you the length of each member and they are giving you the elasticity value. And further, they are giving you the cross section of each member. Each member has got a square cross section and that square cross section is 10 mm by 10 mm. And all joints are pin joints. So this one here is a pin joint and this one here is again a pin joint and this one here is again a pin joint. So these are the pin joints. Now they are asking that what is the load, what is the stress in AB segment. They are asking that what is the stress in AB segment, what is the stress in member AB. Now this problem confused so many students because I know and I've discussed this with number of my students who appeared in GATE 2016. What people did here is, people to find out the load in AB member, people resolved this P load along AB. And that's a very wrong approach. I never told you that you have to calculate the load by resolving. My dear friends, you always have to calculate the load either by following the concept of either side, or if that doesn't work, then you will have to use equilibrium. So do remember, whenever you have to calculate the load, the very first thing that you will have to try is either side. But here either side is going to be a little complicated. Why? Because any one side is a support present. So first of all, you'll have to calculate the reactions if you go for either side. Sometimes direct equilibrium is going to work even quicker. Using directly equilibrium is going to solve the load value even more quickly. For example here, but please be very careful and please keep this in your mind that you're never ever going to resolve the forces to calculate the load. Please never do it. Alright, just in case if either side doesn't work, just in case if this concept of either side doesn't work, if this concept of either side seems to be complicated, then you better rely on equilibrium, but never ever do any resolving of the force to calculate the loads. Please never do it, okay? Please never ever do it. So let's go ahead and use equilibrium to calculate the load. Using equilibrium at this particular joint, we can very clearly see at this particular joint we have 3 loads. We have one load P that we are applying and we have another load that will be induced in BC segment and we have yet another load that will be induced in AB segment. Now guys, let us select the X and Y axis. Let us select the X and Y axis in such a way that X axis coincides with the BC segment and Y axis is the axis perpendicular to BC segment. And let's try to use the equilibrium. Let us try to use the equilibrium along Y axis. Let's try to balance all these forces in Y direction. Now in Y direction, you can very clearly see that P doesn't have any effect in Y direction. And similarly, this PBC also doesn't have any effect in Y direction. So P doesn't have any component in y direction. PBC also doesn't have any component in y direction. PAB has a component in y direction. PAB, if this angle is theta here, then PAB will have some component in y direction, and you can write PAB cos theta is equal to 0. So interestingly, we have only three forces, two of them are collinear. Because two of them are collinear, I have selected the x-axis along that collinear line of action only, and that's how we get PAB value 0 here. Interestingly, if PAB value is 0 here, then my dear friends, sigma AB is also going to be 0, because if the load is 0, then the stress is also going to be 0. So this was a very conceptual problem. People got confused in this. People got, this wrong concept here, that they resolved P along AB and they calculated the stress. That's not how you're going to do the things, because equilibrium is the universal principle. Equilibrium is going to reveal the true picture, that how much force is being resisted by what member. So the why it is happening, you think about it, why AB doesn't have to participate, why AB is not resisting, why the load in AB is getting 0. Because my dear friends, you're applying the load along BC. So BC is going to resist entire load, and any other member doesn't have to take any load. And that is how AB member has the 0 value of load. A 0 value of load results into a 0 value of stress. So this is how you crack this. Now, as a next problem, let us try solving. As I promised earlier, that I'm going to tell you about the partial restriction. So as a 14th problem, we have this interesting problem that they asked in 2016. Now you see that there are so many 2 marks problem that they have asked, either from the elongation concept or from the thermal stress concept. Now this is a partial restriction problem. Why this is a partial restriction problem? Because at one side you have a fixed support, at another side you have a support available at a gap of 0.2 mm. Alright, now this 250 mm length rod has been placed between these two rigid immovable walls, and there is a clearance of 0.2 mm at the right side, and then temperature is being increased by 200 degrees Celsius. If the elasticity value is given to us 200 gigapascal and the coefficient of thermal expansion is given to you as 10 power minus 5 per degree Celsius, then you will have to calculate the axial stress developing in the rod. Then they are asking you to calculate the axial stress developing in the rod. Now, whether it is complete restriction or it is partial restriction, you think about it. A complete restriction is going to be a complete restriction is going to be such that you don't have any permission. Both the extremes are completely restricted. Whereas, my dear friends, a partial restriction is going to be the case where one end will be having some clearance. At one end, some clearance will be there. Alright, something will be allowed. But it's not necessary that such a case will represent restriction. Such a case might also represent the no restriction scenario. I'll tell you why and how. You just keep following, you just be very attentive and try understanding. First of all, you calculate in such problems where it seems like it is the case of partial restriction. You begin with calculating the thermal expansion. Thermal expansion is alpha L delta T. Thermal expansion is alpha L delta T. Alpha is 10 power minus 5 and L is what? The length of the rod is 250 mm and delta T is what? You're increasing the temperature by 200 degrees Celsius here. you're increasing the temperature by 200 degrees Celsius. So guys, you have 3 zeros getting nullified here, and you get 0.5 mm free expansion in the rod if the rod was free. If the rod would be totally free, it must have expanded by 0.5 mm. How much you are allowing? You are allowing 0.2 mm. So do remember, whenever your free expansion, whenever your thermal expansion is more than what you are allowing, that means it is representing the case of restriction. But sometimes, just to confuse you, sometimes just to trap you, they might put up a variation here. They might allow more than what is needed. So rod is going to expand by 0.5 mm, but suppose if I allow 1 mm here, then there is no restriction. Why? Because whatever the rod is wanting to expand, I'm allowing it. I'm permitting it totally to be expanded. So my dear friends, please do remember that in such problems there is one more variation. If free expansion is less than the allowed expansion, then you will still treat it as a no restriction case. And you know, in case of no restriction case, you know that in case of no restriction case, thermal stress is gonna be 0. But here we have the restriction or not. You think about it. Restriction is present or not. So 0.5 mm is what the rod wanted to expand. How much you are permitting? You are permitting 0.2. So that means you are restricting how much? If 0.5 is what the rod wanted to expand. If the rod was free, it must have expanded by 0.5 mm. How much you are allowing? How much you are permitting? You are permitting 0.2 mm. So naturally you are killing how much? You are restricting how much? You are restricting 0.5 minus 0.2. So let us now calculate the restricted part. The restricted part of expansion is whatever the rod must have been expanded if it was free, minus whatever you are allowing. So the restricted part of the expansion is nothing but 0.3 mm. Alright, now this restricted part of the expansion, divided by original length, this is gonna give you the strain that is representing the restricted strain. And restricted strain multiplied by elasticity. Restricted strain multiplied by elasticity, this is gonna give you the stress value. This is going to give you the thermal stress value. So you get thermal stress value simply as elasticity multiplied by this restricted expansion divided by original length. Now elasticity value is given to you here. You see, elasticity value is 200 gigapascal, and delta L restricted we have calculated already. And what is L given? L is given as 250 mm. So my dear friends, every single thing is known to you. Elasticity value is 200 into 10 raised to 3, and delta L, that is restricted part, is 0.3, and length value is 250. You can simplify this. If you simplify this, you get 200 into 10 raised to 3 multiplied by 0.3 divided by 250, and this is gonna be like 25 and 200, this is 8, and we get finally 8 into 10 power 2, because 1 0 will get cancelled, into 0.3. So finally we get 240 megapascal. So if you are continuously watching my sessions, you know that I have solved every single variety of the problem through these gate problems. I've solved thermal stress problems where there is no restriction. I have solved thermal stress problem where there is complete restriction. And now, just now, I have solved the thermal stress problem where you have partial restriction. Now, this particular problem we have already solved where elasticity was varying. Let us try solving this problem, this 2018 problem that they asked for 2 marks. They asked this particular problem for 2 marks, this 2018 problem. Let us try solving this. Here you have a steel segment and you have aluminum segment, and in both the segments the strain has to be 10 power minus 6 and 10 power minus 6. The area is given as 1 meter square and the elasticity for aluminum is 70 gigapascal and elasticity for steel is 210 gigapascal. You see how easily I picked up the values. You just read the main part. And that's how you are going to save the time. Strain is 10 power minus 6. Strain is 10 power minus 6. And elasticity for steel is 210 gigapascal. Elasticity for aluminum is 70 gigapascal. Area of cross section is same everywhere and that is 1 meter square. And we are applying this load P here at the junction. Alright, now they are asking that to produce this much strain, to produce this strain and to produce this strain, what is the load that we are supposed to apply? This problem we can solve very easily. This particular problem we can solve very easily by considering internal forces, that at the junction here at the mid you are applying this P and you have this part fixed and you have this part fixed again. This segment is made from steel, this segment is made from aluminum, this segment is made from steel and this segment is made from aluminum. Now I'm going to take a section in steel and I'm going to take a section in aluminum and I'm going to draw the free body diagram. I'm going to draw the free body diagram of only this much part. Only this much part will be represented separately as a free body. Why I'm doing this? Why exactly I'm adopting this particular approach? Because my dear friends, strain is given to you in steel also and strain is given to you in aluminum also. And strain multiplied by elasticity becomes what? Strain multiplied by elasticity becomes stress. And stress multiplied by area becomes what? Stress multiplied by area becomes load, respective load in steel and respective load in aluminum we can calculate. So this is why, because a strain is given, using that strain value I can calculate the stress value, and using that stress value I can calculate the load value. That's why I'm cutting it in between. Now let us draw the free body diagram of this much part only. In this much part we are applying P at the junction, and to oppose to that P, to resist to that P is acting as a tensile load as far as steel is concerned. So for steel there is going to be some tensile load developed, and for aluminum the same load is acting as a compressive load. For aluminum the same load is acting as a compressive load. Now you can see in this free body diagram, if we balance everything, we have the load in positive x direction as P and the load in negative x direction is nothing but P steel plus P aluminum. Now I'm going to replace the load as stress multiplied by area, and once again the load as stress multiplied by area, because area is similar, because area of cross section is similar for steel and aluminum. So I'm not writing the suffix in area. And then stress can be written as elasticity multiplied by strain, elasticity of steel multiplied by strain. Here again stress can be written as elasticity multiplied by strain. Now strain is also similar. Actually it has to be similar. Why? Because by whatever amount steel will get elongated, by the same amount aluminum will have to be compressed. You think about it. Because here you have a fixed support at the left extreme and you have a fixed support at the right extreme. Because you have a fixed support at the left extreme and you have a fixed support at the right extreme. So there is no other compatibility. The compatibility is that by whatever amount steel is going to expand, by the same amount aluminum will have to get compressed. So what other variation is possible here? That they would have given you only the stress value, only the strain value in one material. The other material will have to have, the other material, that other material will be having the same value of strain. So guys, the strain value is also equal. Of course, you'll have to consider the magnitudes only here because the appropriate direction of the load we have already taken into account. So now epsilon and A, that is going to get cancelled. Epsilon value and A value, that is going to get common. I'm sorry, not cancelled but common. And then you have elasticity of steel and elasticity of aluminum and strain and area. Now let us put all the values. Elasticity of steel is given as 210 into 10 power 3 megapascal. Elasticity of aluminum is given to you as 70 into 10 power 3 megapascal. And area is given as 1 meter square. Let me change that meter square to mm square. So if I change that meter square to mm square, I'll have 10 power 6 mm square. And because elasticity values are represented in megapascal, you know already megapascal is nothing but Newton per mm square. So mm square and mm square is going to get cancelled. You can simplify all this. Epsilon value, by the way, is given to you. Epsilon value is 10 power minus 6. So this 10 power minus 6 and this 10 power 6 is going to nullify each other. Now what is left end of the day? 280 multiplied by 10 raised to 3. 280 multiplied by 10 raised to 3 Newton. This is left. So you get 280 kilonewton load that will have to be applied. So guys, you notice end of the day that we have all these problems we have solved using just 3 to 4 concepts. Now I'll humbly request this to you that please solve all these problems by yourself again, because solving previous year problems, particularly if you're solving last 20 years problems all by yourselves, then it gives you very good command and very good variety. People nowadays, I see people keep distracting themselves from here to there to there to there, and they keep searching for so many problems. At my time of preparation, I solved previous year problems, but I never looked at the solutions. So I would recommend you to keep solving more and more and more and more and more previous year problems. They give you variety, they give you command, they give you confidence. Thank you very much for watching the session. Before you wind it up, just make sure that you hit the bell icon to keep receiving the notifications of my videos. And whenever you're going to subscribe for Gate Plus packages, make sure that you use my code MTLive to get 10% additional discount. Thank you very much.